Okay, I'm going to try and demonstrate how to process the data here. Hopefully this is going to work. So here we've got the data from the alcohols lab that you guys did on Tuesday. You can see that I've pre-filled a few values here at the top of the screen. So 32.05 is the molecular mass of methanol, 0.385 is the specific heat capacity of copper, which we'll need for the calorimeter, and 4.18 is the specific heat capacity of water, which we're going to need as well. So the first thing I'm going to do is I'm going to enter the molecular masses of the other alcohols based on this one here, knowing that as we go down the series, we're adding CH2 each time. That's 1 carbon, 2 hydrogens, which means we're adding 14.03 to the molecular mass for each of these molecules. So in order to do that, I can enter a formula here. So equals, highlight the cell which has got the molecular mass of methanol, and then put plus 14.03. When I hit enter, you can see it's got 46.08, which is the molecular mass of ethanol. I can then do the same thing for each of the other alcohols as we go down. Each time I'm highlighting the previous one and adding another 14.03 to add on an extra carbon and an extra 2 hydrogens. Okay, right, so I've got those entered. I'm now going to start processing the data that we've got. I'm going to first of all do methanol, then we're going to go and copy everything through to the other alcohols. So the first thing I'm going to need to do is add an extra column next to the masses for the change in mass. So I'm going to highlight the entire column by clicking on F, right click, press insert, and that will add a column in here. Into this box here, I'm going to enter change in mass. I'm going to use the delta symbol for that. So to insert a symbol, I can go to symbols here and I can select the delta, press insert, and it's now appeared. Now I can add mass, and I'm also going to add the uncertainty value. So again, I'm going to insert the symbol, and this time I'm going to add the plus minus symbol, because the uncertainty of mass here is going to be plus or minus 0.02 grams. So we have that here. In order to actually make it appear visible, I can wrap the text, which is this button here that's got like the A, B, and a C with an arrow pointing to it. If I click on that, the text should appear. Now, unfortunately, this cell is not quite tall enough to display it. So I'm going to make it a bit deeper, and you can see that appears there. I'm now going to do the exact same thing in this column here for the change in temperature. So again, I'm actually just going to copy this because it's easier. Copy that in here. And then where it says mass, change that to temperature. And where it says plus or minus 0.02, I'm going to change that to plus or minus 1. Because remember that each time we use a value, we need to add the uncertainty. So here we're finding a difference in mass and a difference in temperature, which means we need to add together the uncertainty of the initial mass, the uncertainty of the final mass, when we have our difference in mass. So it doubles the uncertainty, and the same with our temperatures. So in order to calculate our change in mass, I can go to the first cell here, press equals, and then I'm going to go the larger value minus the smaller value. So I just click on the cells with those numbers in. When I hit enter, the number then appears. I always do larger minus smaller because that will give us a positive number. In order to use this for all of the cells here, on the corner of the cell there's this little square. If I drag that down, that will then make those values fill automatically into all of the other cells in that column. I can do exactly the same thing with temperature, so equals the larger temperature box minus the smaller temperature. Again, hit equals, and then drag those down to give us our change in temperature values. Okay, once we've got those, we're now going to start calculating in order to find the delta H, the enthalpy change of combustion of the alcohol. So we're going to need the Q values first, and we need to have the Q values of both the calorimeter and the Q value of water, which we will then be able to find the total Q from. So in order to find that, we need to use Q equals MC delta T. M in this case is going to be the mass of the calorimeter. So I press equals, then I can click on the cell which has the mass of the calorimeter, multiplied by the specific heat capacity of the calorimeter, which is 0.385 because it's made of copper. So that's the specific heat capacity of copper up here. So I click on that, multiplied by the change in temperature, which was the value that we just calculated here in this column. Now, before I click out or before I hit enter in this cell, I'm going to go up here to the editing bar, and I'm going to make my cursor go in front of where it says, in my case, J1, which is the value of the heat capacity of the calorimeter, and I'm going to press a $sign in front of the J and a $sign in front of the 1, and this way it's always going to be taking a value from that cell at the top, this J1 cell, which has the heat capacity of copper, rather than taking the value from the equivalent cell as it goes down the column, which will eventually end up being values from somewhere here, which we don't want. So when I hit enter, it's going to have the Q value for the calorimeter, and again I can drag this down to fill everything in the column. And I can do exactly the same thing for water. So equals the mass of water, which is 200 grams. Remember, 1 gram is the same as 1 centimeter cubed, times by the specific heat capacity, which is 4.18, which I put up here, times by the temperature change, which is in this column here. Once again, I always wanted to take from this cell, so I put a little $sign in front of the K, a little $sign in front of the 1 before I hit enter, and then again I can drag this down to automatically fill everything in this column. The Q total is just the sum of those two values, so equals, click the cell with the calorimeter, plus, and then click the cell with the Q for the water, and then again I can drag this down for everything into this column here. The next value that I'm going to need in order to find the delta H is the moles of the alcohol that we were burning. So in order to find the moles of the alcohol, that is mass divided by molar mass. So again, I can press equals. I can find my change in mass value, which is in this column here, so 1.505, click on that cell, divided by, and then I can click here on the molecular mass of the methanol. Whoops, what's happened there? Let me just repeat that. So click on mass, divided by the molecular mass of the methanol. And once again, I always wanted to take from that cell, so I'm going to put little dollar signs here. And then it's going to calculate the moles of our alcohol according to the masses that each person got here. And now we can use that in order to find our delta H. So once again, I'm going to insert a symbol, insert delta H, and it's going to calculate it in joules. So I'm just going to put this in here. So delta H is negative Q divided by moles. So again, equals minus, click on the Q total, divided by moles, click enter, and I can drag this down here. And I'm actually going to make another column with the value in kilojoules, which is simply going to be the value here divided by 1,000. Just to give ourselves slightly more workable numbers. So we now have values for the enthalpy change of each of our alcohols. We can actually average these. So what I'm going to do is I'm going to put a box here, and then in order to calculate the average, I can press equals, and then rather than clicking in any boxes, I can now type av, and I get a little drop-down menu, and I'm going to click average, double-click on that, and it now has an open bracket, and it wants me to highlight some cells. So I'm going to highlight all of these cells for all of these alcohols. Then I'm going to close the brackets, press enter, and it has calculated an average value here. So we've now got the average enthalpy change of combustion of methanol. But before we go any further, before we do the same thing for all the other alcohols, we're also going to calculate the uncertainties using this process. So I'm going to add a few extra columns. So I'm going to add an extra column between the mass of the calorimeter and the volume of the water. So I'm just going to press insert. An extra column between the volume of water and the initial mass of the spirit burner. An extra column between the change in mass and the initial temperature of the water. Note that each time I'm clicking on the letter at the top of the column, not on the number, and that creates a whole column. An extra column between the change in temperature and the Q of the calorimeter. And an extra column next to each of these values that we just calculated for each of these things that we've done here. So I've now got spaces where I can calculate my uncertainties, and they're going to be percentage uncertainties. So I'm just going to put little percent signs into each of these boxes just so I know what I've got there. Oops, gone too far. And in order to calculate the percentage uncertainty, what I'm going to do is I'm going to do equals, open brackets, the value of my uncertainty, so 0.001 in this case, divided by the mass value that we're interested in, close brackets, multiplied by 100. And I can now drag this down to fill all of these values in. And I can do the same here for the percentage uncertainty of the water. So equals, open brackets, 1, which is the uncertainty of our measuring cylinder, divided by the mass of our water, or the volume of our water, close brackets, times 100, which is 0.5%. Drag that down. Do the same here. So equals, open brackets, 0.002. Remember that our mass uncertainty has doubled when we found the change in mass, divided by our change in mass, close brackets, times 100. Drag this down, and the same here for our change in temperature, so equals, open brackets, 1 divided by the change in temperature, close brackets, times 100, gives us 4.8%. Note that the number of decimal places doesn't really matter for these, and that's given us the value for each of these values that we have here. Now for the percentage uncertainty of our Q value, these were calculated from the values we've got here. So here we just need to add together the relevant uncertainties. So here we used the mass of the calorimeter. So I'm going to highlight the percentage uncertainty of the calorimeter. And we used the change in temperature. So I'm going to add the percentage uncertainty of the temperature change. And that's it. I can drag those down here. And I can do the same with the percentage uncertainty of the water. So here we've got the mass of water, so 0.5 plus change in temperature, press enter. We've now got the percentage uncertainty of the water. And of course the Q total is going to be the percentage uncertainty of the calorimeter plus the percentage uncertainty of the water. So that basically doubles our uncertainty here. And for the moles, the percentage uncertainty here is exactly the same as the uncertainty percentage of our mass, since the molar mass had no uncertainty. So what I can do is just click on that, press equals, press on that, and that's all. And that's just going to directly transfer that value across. The delta H, the uncertainty, is going to be the uncertainty of the Q and the uncertainty of the moles added together. So I have the uncertainty of the moles of the Q plus the uncertainty of the moles. And for some reason it doesn't like that. Let's just remove a few. No, it doesn't like that. Why does it not like that? Oops. Percentage uncertainty there, plus percentage uncertainty here. That is very strange. Okay, it's because the number is far too long, so I'm going to shorten the number here by clicking on this button here, where you can see there's like a little arrow pointing to the right. That shortens our number up so that it fits in the box. Okay. Again, like I said, the number of decimal places really doesn't matter here. Now the last column here is going to have the final absolute uncertainty. Again, the box is not quite deep enough. Let's just make it wider so it fits. Okay, so to find the final absolute uncertainty, we need to find this a percentage and apply this percentage to this value. So what I'm going to do is I'm going to go equals, open brackets, this value here, divided by 100, that's to give us 1% of it, and then multiplied by the percent value here, whoops, didn't do it, multiplied by the percent value here, equals, gives us an uncertainty value as an absolute. Now this has got a whole ton of decimal places. Remember that absolute uncertainties are only allowed to have a single significant figure. Now even if I click this button here and get rid of all of the decimal places, I still can't get it to a single significant figure for many of these. Remember that if it's got a 1 as the first digit, I can have 2 significant figures. However, for the rest of them, I'm going to have to make 1 significant figure. So 40 is fine, 11 is fine, 18 is fine, 40 is fine. 24 will go up to 30, 39 will go up to 40, 32 will go up to 40, 25 will go up to 30, and 44 will go up to 50. 30 will stay as 30, 40 will stay as 40. So my largest value, remember we always round absolute uncertainties up, is going to be this one here, which will be rounded up to plus or minus 50 kilojoules. So the one that we're going to use is going to be plus or minus 50 kilojoules. Now, doing that, we can now round our final delta H, our average delta H value, so that it matches the number of significant figures, or rather the number of decimal places in our absolute uncertainty. So I'm going to bring this, and actually this doesn't quite work. So once again, we've got to get rid of the 96 and round it up to 100, because 96 is more than 5. So this time we round up or down in order to have a value that matches the number of digits in our uncertainty. So our average uncertainty here is actually going to be minus 300 kilojoules. I'm just going to type that in here and replace it. So what I can now do is I can now take those values and fill them down for our other alcohols. So I can take my percentage value here, I can copy that to there, I can copy that to here, I can copy this down into each of our alcohols. Now note that it's going to be pulling the values out of the appropriate cells each time. I'm going to have to add an extra one here because Anna only collected data for a couple of the alcohols before she had to leave. So now we've got the uncertainty, percentage uncertainty of the mass of the calorimeter. I can do exactly the same with the percentage uncertainty of the water. For each of the alcohols, remembering once again to just pull the values down for these two. And then I can do the same with these values here. Now I'm just going to copy the first 2 cells across just to show you that it's going to work for all of these. It's going to copy from the appropriate cell, so you can see this one says F21, G21. If I go down to the next line down, it goes F22, G22, and so on. So the bottom one will be F33, G33. So I don't need to actually copy the whole column. I can just copy the 2 cells, copy those into the top of each column. Like so. And then just drag those down to fill the values into each column. Okay, and then the last columns, I can just copy the whole thing, making sure that I place it into the right cell. And again, it should pull all of the appropriate values out. Now, the one that we need to be careful of here is, first of all, dragging down this line here, this line here. But the value that we need to be careful of is the moles value. So here, the Q's of the water and the Q's of the calorimeter, they are pulling the same value. So N1 and N value cell N1 and P1, which is what we want them to be pulling from, because they're pulling the specific heat capacities. However, in our moles, currently they are all referring to the moles of methanol. So we're going to have to fix the row number so that it refers to the appropriate molar mass of the alcohol that we're looking at. So here for ethanol, I'm going to just highlight the first cell here, and where it says L1 here, I'm just going to change the 1 to an 18, and it will now be pulling from this cell here. And I can drag that down, and we should see all of those moles values change accordingly. Now I'm going to do that for each of these alcohols. So again, where it says L1, I'm now going to change it to L36, which, as you can see, is highlighting the molar mass of propanol. And again, I'm going to pick that cell, drag it down, and I'm going to do the same for each of them. So here I'm going to make it 54. Drag it down. Here I'm going to make it 71. Drag it down. And here I'm going to make it 88. Drag it down. So now the moles values have all been corrected. All of the other values were referring to the correct thing, since they were all pulling things from across the table, and the C values for the calorimeter and the water will remain constant for everything. So what I can now do is I can now find my averages for each of these different alcohols. I'm not going to write the word average each time. So equals average, double click average, highlight these, press enter, and in fact I can copy that function and I can type it in here, and I can just check if it's pulling from the right cells by just clicking where it says X39 colon X51, and you can see that it's highlighted the right cells. I can now do the same here, and it doesn't like that. And the reason why it doesn't like that is because we've got less rows. So I'm going to again do the same thing. Average, double click, highlight all of those, close the brackets, press enter. Again, I can copy that function. It should now work because these have all got the same number of cells. So I've now got average values for each of the different alcohols, and I can also use my absolute uncertainty values for each of these to actually do the rounding. So my absolute uncertainty here, I'm going to look for my biggest one, which is 83, which means I'm going to round this up to 90. So 90 is going to be my plus or minus, which means once again I need to round up 597 to 600, so minus 600. This one, my biggest value is 148, which I can keep the 1 at the beginning, but I've got to have 15. Remember, always rounding up. So here I'm going to round down to minus 950. So you can round this up or down. Uncertainties can only ever go up, so minus 950. Here, my biggest value is 175, so that's going to be 180. So I'm going to round this to 1,280, because I'm going to round that up, so minus 1,280. Here, I have to round to my answer. My biggest uncertainty here is minus 208. Now, since the first digit is a 2, I have to round this up to 300. Which means I now need to round this into the hundreds value. So I have to round this either to minus 1,200 or 1,300. Since it's close to 1,200, I'm going to round this to minus 1,200. And for the last one, again, my biggest value is 242, so that's going to be 300 as our uncertainty, which means I need to round this value again into the hundreds value. This time I'm going to round up because 1,562 is closer to 1,600, so negative 1,600. So I now have delta H values for each of my alcohols. I'm just going to make a new table down here. I'm going to put it over here. I'm going to put the name of the alcohol. I'm going to put the number of carbons. I'm going to put the delta H value. Let's just copy that here, and the uncertainty. So methanol, ethanol, propanol, butanol, pentanol, hexanol. My number of carbons is simply 1, 2, 3, 4, 5, and 6. And then I need to take my values that I've worked out here. So minus 300 and 50 for the uncertainty for the first one, minus 690 for the second one, minus 950 and 150 for the third one, minus 1280, and 180 for the fourth one, minus 1200 and 300 for For the fifth one, oops, I've got to redo that. And minus 1600 for the last one. Okay, so now that I've got all my values, I can make it look like a nice table by just dragging over it, clicking up here, selecting all borders, so now it looks like a table. I can now make a scatter graph. So it's got to be a scatter graph, not a line graph. So highlight the columns with the number of carbons and the delta H. Don't highlight the uncertainty column, don't highlight the name of the alcohol column, so it's just the middle two. You can keep the titles in there, it doesn't really matter. Go to Insert here at the top, and then you're going to go to Chart, and you need to make sure it's a scatter chart, not a line chart. So not this one here. So when you insert a scatter chart, you get this little picture, and you want to pick the first one, which has got just a series of dots. Click on it, and your chart will appear. Now, we're going to do a few changes on this chart just to make it a little bit more user-friendly. The first thing we're going to do is we're going to click on the data points. Once we've clicked on the data points, we can right-click and say Format Data Series from the drop-down menu. So that will open up a menu bar here on the right. We'll go to the first option here, the one that looks like a little bucket. We'll click on Markers. We'll click on Mark Options, and we're going to change it from automatic to built-in, and from type from a blob to an X. Okay, so now we've got X's as our data points. Now we can add a trend line to here. So the easiest way to do it, well, actually we can use this plus here in the corner. We can add a plus, we can select trend line, and we want it to be a straight line. You do have options, but we do want a straight line trend line, so we can add that in here as well. So we now have a trend line. The final thing we need to do is we need to add error bars, and we're going to use our absolute uncertainties to give us our error bars. So again, you can see here on this menu from the plus button, there is an option to add error bars, and if you click on it, we end up with these plus and minus error bars in both the horizontal and vertical axis. We don't want the horizontal ones. So we're going to click on the horizontal ones until they're all highlighted, and then just press delete, and they disappear. The positive ones at the moment are not based on anything at all. They're just values, but they're not actually very useful. We're going to want to change these. So we want to highlight them, so click on them so they're highlighted. And you can see that we've still got this menu over here on the right-hand side. If you don't have it, you can right-click on it and get this Format Error Bars menu, but since we have it still, we don't need to do that. And then over here on the right-hand side, we're going to go to the third of these three options, the thing that looks like a bar graph. When we click on it, you can see we've got some options, and the one we're looking at is the error amount option, which we want to change to custom, and then we want to specify value, which is a little bit off the screen here, but here it says specify value. We click on that, and it's going to open up this box, and it's going to say positive error value, and it's going to have already highlighted the thing that's in the box, and we can now just go back to our table and just highlight our absolute uncertainty values, and you can see that it puts in a bunch of values here. We can then go to the negative error bar space, just delete everything that's in there, and again highlight everything in that table, and we can now see that we've got the same thing in both of these boxes on the positive and error bar values, and what they are is in fact the cell references for the cells where we put our absolute uncertainties. When we hit OK, the error bars will now appear on our plot. So now we've got our data on here with the instrumental uncertainty illustrated by these error bars, and we can see that the instrumental uncertainty gets larger as the size of our alcohol gets bigger, but we have that there. Now there's one final thing that we can actually do here, and we can actually use this graph to compare our experimental values with literature data. So I need to find literature data of the enthalpy of combustion of the alcohols. Now if I look into my data booklet, you will find values for the first 4 alcohols, but not the last 2. So what I'm actually going to do is I'm going to open a browser window, and I'm going to search for enthalpy change of combustion of the primary alcohols. You can see I've already looked for it before. Search for that, and in fact the very first source that we've got here, which says Doc Brown's Chemistry, I can click on this, and we scroll down a little bit, and they've got a table here which has the enthalpy changes of combustion of the alcohols. Now, in order to actually do this, so negative 726, oh, it disappeared, that's annoying. -726. I was going to put this on another screen, but I'm copying these across from that table there. So -1367, -2021, -2676. So those are all the same, exactly the same as what is in your data booklet from the IB. They're in fact values which are published by the International Union of Pure and Applied Chemists, which is where the IB gets its data from. But this site just has all 6 of them, plus a few extras. So -3984. So I've now got the literature values, and just to kind of prove that I'm not making these up, I've taken the first 6 literature values here from this table, which we're going to use. I'm also going to copy the source just to show you where it comes from, and I'm going to put this down here so that we know that we're not just making up data. Now I want to add this to my chart. So what I can now do is I can again go to my plus button. No, I don't want to go to the plus button. I want to add a data series. So select data. If I click on select data, I get this little window here. Now you can see that it's already highlighted the bit that we had highlighted before, which was the number of carbons and the delta H. The arrow bars bit doesn't get highlighted because we added those in separately. But here where it says legend entries, I can add a series. And if I click on that, I get this box which says edit series. I can put series name, let's call it literature, or let's call it lit. My series X, if I click into this box here, the x-axis values, those are my number of carbons. So again, I can highlight my 1 through 6 and the number of carbons. Then I can go to my y-axis value, and I can highlight that column of literature data that we've just inserted. Now when I click OK, it comes back to this. If I click OK again, a new set of data appears on our graph. And again, I can once more change the marker options to make them into crosses because we don't like blobs. And I can once again add a trend line. And now we can actually discuss this to compare the data that we've got experimentally versus the literature data. We can add a few other things to this. It's a good idea to add a title, and it's a good idea to add some axis labels. So our x-axis is the number of carbons, and our y-axis is the enthalpy change of combustion in kilojoules per mole. I'm just going to use slash here because it doesn't like superscripts. The chart title, I'm going to call this enthalpy changes of combustion of the first 6 primary alcohols. Typo. And there we have it. I can make this a little bit bigger. And here we have our graph of our data, which we can include in our reports. Okay, that's it. Thank you. Hopefully this is helpful.